vector calculus. So this topic can be divided into two subtopics. Number one, vector differentiation and vector integration. First one is vector differentiation. To define the terms in the vector differentiation, first we are supposed to define the differential vector differential operator del, and this can be denoted by del symbol delta, and we call it as del or nabla, and it is defined as del is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, where I bar, j bar, k bar are unit vectors in the directions of x, y and z axis. This is x axis, y axis and z axis. This is I bar, this is j bar, and this is k bar. And this is a vector point function. And this operator can be applied on both scalar functions as well as vector functions. Del can be applied on both scalar functions and vector functions. So first I would like to define gradient. If phi is any scalar point function, phi of x, y, z is equal to c is any scalar function, then gradient phi is denoted by grad phi, and we write it as del phi is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi, and this can be written as I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z, and which is a vector point function. This gradient is always a vector point function. The physical interpretation of gradient is, if phi is any surface, if phi of x, y, z is equal to c is any surface, then grad phi or del phi represented as normal vector to the surface. Normal vector to the surface. Suppose if phi is any sphere, x square plus y square plus z square is equal to 3, it is a function of x, y, z, then grad phi represents the normal vector to the surface at any point p x comma y comma z. And then to find the unit normal vector, normal vector is grad phi. The unit normal vector can be calculated, unit normal vector, this is the second one. The unit normal vector can be calculated by using the formula grad phi by magnitude of grad phi. And the third one is, when we can find the angle between any two surfaces using these normal vectors. Suppose let f is any surface and g is other surface. Let f is any one surface and g is other surface. If we want to find the angle between the two surfaces, it is required to find the angle between the two normal vectors to the surface. So first find the normal vector to the first surface, then find the normal vector to the second surface, then find the angle between them, let it be theta. So to find the normal vector to the first surface, we are required to find grad f. Similarly, to find the normal vector to the second surface, we are required to calculate grad g, and this is denoted by n1 bar and it is denoted by n2 bar, and theta is the angle between the two surfaces, let it be then cos theta is equal to n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. Then theta is equal to cos inverse of n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. And the next definition, fourth one, directional derivative. The directional derivative is defined as if phi is any surface and a bar is any vector, the rate of change of phi in the direction of a bar is defined as directional derivative. The rate of change of phi in the direction of a bar is defined as directional derivative of phi in the direction of a bar. And here the formula is directional derivative is equal to grad phi dot a bar by magnitude of a bar. The directional derivative can be calculated by using the formula grad phi dot a bar by magnitude of a bar. And also the maximum directional derivative, the maximum directional derivative will be obtained in the direction of grad phi. That means the formula will become grad phi dot grad phi by magnitude of grad phi. This is the directional derivative in the direction of a bar, and the maximum direction derivative will be the directional derivative in the direction of grad phi. So the formula will become grad phi dot grad phi by magnitude of grad phi, and the resultant is magnitude of grad phi. So this is the formula to find the maximum directional derivative. So we have four formulas. The first one is finding normal vector to the surface, then finding unit normal vector to the surface, then finding the angle between the two surfaces, then directional derivative, and also maximum directional derivative. Problems. Find grad f, where f is equal to x cube plus y cube plus 3xyz at the point 1 comma 1 comma minus 2. Solution: given f is equal to x cube plus y cube plus 3xyz, grad f is equal to del f is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x cube plus y cube plus 3xyz. So in operating the function with dou by dou x, so dou by dou x means it is a partial derivative with respect to x. So we know that the partial derivative with respect to x means the other variables treat as constants. We get dou by dou x of x cube 3x square, y cube 0, 3xyz will give 3yz. That is the first term, plus j bar into dou by dou y of the entire term, x cube 0, y cube 3y square, 3xyz will become 3xz. That's the last term, k bar into, since we are doing partially with respect to z, first term 0, second term 0, third term will give 3xy. Now grad f at the point 1 comma 1 comma minus 2 is equal to, so x1 y1 z minus 2, so I bar into 3 minus 6 plus j bar into 3 minus 6 plus k bar into 3. that is equal to minus 3i bar minus 3j bar plus 3k bar. So which is the our required grad f at the point 1 comma 1 comma minus 2. Find a normal vector to the surface x square y plus 2xy minus 4z at the point 2 comma minus 2 comma 3. So normal vector means we are required to find grad f. So let the given surface f is equal to x square y plus 2xy minus 4z. Now normal vector is equal to grad f is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x square y plus 2xy minus 4z, which is equal to I bar into dou by dou x of x square y 2xy, dou by dou x of 2xy 2y, 4z derivative 0 plus j bar into dou by dou y of x square y x square, dou by dou y of 2xy 2x, last term will be 0 plus k bar into dou by dou z of first term 0, second term 0, last term minus 4. So now grad f at the point 2 comma minus 2 comma 3 is equal to, so 2 into minus 2, I bar into minus 8 minus 2 into minus 2 minus 4 plus j bar into x square 4 plus 2 2s are again 4 plus k bar into minus 4. It is minus 12i bar plus 8j bar minus 4k bar. So which is the normal vector at the given point. Find the unit normal vector to the surface x square plus y square plus z square is equal to 26 at the point 2, 2, 3, 2 comma 2 comma 3. We know that unit normal vector can be found for any surface or for any function by the formula unit normal vector is equal to grad phi by magnitude of grad phi. Here given phi is x square plus y square plus 2z square minus 26. Now grad phi is equal to, so del operator I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of x square plus y square plus 2z square minus 26. So on operating with dou by dou x, I bar into dou by dou x of the entire function 2x, y term 0, z term 0, constant 0. Similarly plus j bar into dou by dou y of this function, we get 2y, x term 0, z term 0, 26 constant 0. Similarly plus k bar into dou by dou z of 2z square, 4z, x square term 0, y square term 0. Now at the point 2 comma 2 comma 3, grad phi is equal to 2 2's 4I bar x2. Similarly y also 2, so 2 2's 4k j bar plus 3 4's 12k bar. And grad phi is equal to, magnitude of grad phi is equal to square root of 4 square plus 4 square plus 12 square. It is root of 16 plus 16 plus 144. It is 160, 176. 144 plus 6, 150, 160, 176. Therefore, unit normal vector is equal to grad phi by magnitude of grad phi, that is 4I bar plus 4j bar plus 12k bar by square root of 176. That is the required solution. Fourth problem. Find the greatest value of the greatest value of the directional derivative of the function f is equal to x square y z cube at the point 2 comma 1 comma minus 1. Find the greatest value of the directional derivative. So you know that simple question, maximum directional derivative is equal to magnitude of grad f. That is our formula. So here f is equal to x square y z cube. The maximum directional derivative means the directional derivative in the direction of grad f. That is magnitude of grad f. Here given f is x square y z cube. And consider grad f. Grad f means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x square y z cube. So now operating with dou by dou x, first I bar into x square 2x, y and z cube terms are constants. Y z cube plus j bar into dou by dou y of this one. X square remains same, y 1 అయిపోతుంది, z cube plus k bar into 3x square plus k bar into 3x square y z square. Z cube derivative 3z square. Now grad f at the point 2 comma 1 comma minus 1 is equal to, so substituting the points 2 1 4 into minus 1, minus 4I bar plus j bar into x square 4 into minus 1, it is minus 4j bar plus 3 into x square, 2 square 4, 4 3s are 12 plus 12k bar. It is grad f at the point 2 comma 1 comma minus 1. Now maximum directional derivative is equal to magnitude of grad f, it is square root of 4 square 16, again 4 square 16 plus 12 square 144 is equal to square root of 176. That is the required solution. Next problem, fifth problem. Find the directional derivative of the function f is equal to 2xy plus z square at the point 1 minus 1 3 in the direction of the vector I bar plus 2j bar plus 3k bar. Already I have given the formula. The directional derivative is equal to the directional derivative of phi or of f in the direction of a bar. In the direction of a bar is grad f dot a bar by magnitude of a bar. So this is the formula for the directional derivative of the function f in the direction of a bar. Here f is equal to 2xy plus z square, and a bar is the vector given as I bar plus 2z bar plus 3k bar. Now consider grad f I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function 2xy plus z square. So now operating with del, differential operator I bar into dou by dou x of this term. So first term 2y, second term z square will become 0, plus j bar into dou by dou y of this entire term 2x plus k bar into dou by dou z of first term 0, second term will give you 2z. Now grad f at the point 1 comma minus 1 comma 3 is equal to, so in substituting the point y for minus 1 minus 2i bar x1 కాబట్టి 2z bar plus 2 3s are 6k bar. This is grad f at the point 1 comma minus 1 comma 3. Now the directional derivative. So direct formula, the directional derivative grad f, it is minus 2i bar plus 2z bar plus 6k bar dot product with, so a bar, what is a bar? A bar is I bar plus 2z bar plus 3k bar by magnitude of a bar, that is square root of 1 plus 4 plus 9. So now I am making dot product in the numerator. So I bar dot I bar 1, I bar dot j bar 0, I bar dot k bar 0. So now operating with minus 2, I will get minus 2 plus 2 2s are 4 plus 6 3s are 18 by root 1 4. It is equal to 20 by root 14, which is the required directional derivative in the direction of grad phi. In this problem, there may be, you can find maximum directional derivative also. They may ask for maximum directional derivative. Suppose if they ask for maximum directional derivative, the formula will become magnitude of grad f. That is, magnitude of grad f means square root of 4 plus 4 plus 36. It is equal to root 44. This will be the maximum directional derivative, and this will be the directional derivative along this vector a bar, given vector a bar. This is the maximum directional derivative. Next problem, find the angle between the two surfaces x square plus y square plus z square is equal to 9, and z is equal to x square plus y square minus 3 at the point 2 comma minus 1 comma 2. So we know that the angle between the two surfaces is nothing but the angle between their normals. So we know how to find the normal vectors for each surface, given surface. So here two surfaces, let us assume that the first surface phi 1 is x square plus y square plus z square minus 9, and phi 2 is x square plus y square minus z minus 3. Now consider the normal vectors. Grad phi 1, it is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of x square plus y square plus z square minus 9. So that is an operating I bar into, so dou by dou x of the entire function will give you 2x plus j bar into dou by dou y of the entire function 2y plus k bar into the entire function will 2z. Also, grad phi 1 at the point 2 comma minus 1 comma 2 is equal to 4i bar minus 2j bar plus 4k bar, and let this vector be, say, n1 bar. This is the first vector, the normal vector to the first surface possible. Similarly, the normal vector for the second surface, grad phi 2 is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x square plus y square minus z minus 3. It is I bar into dou by dou x of the function 2x, y0, z0, 3 constant 0, plus j bar into dou by dou y of the function x term 0, y square 2y, z term 0, constant 0, plus k bar into minus 1. So this is 2xi bar plus 2yj bar minus k bar. And grad phi 2 at the point 2 comma minus 1 comma 2 is equal to 4i bar minus 2j bar minus k bar, and call this is the vector n2 bar, the second normal vector. Now angle between the two surfaces cos theta is equal to n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So already we got n1 bar as 4i bar minus 2j bar plus 4k bar, the dot product with the second vector 4i bar minus 2j bar minus k bar by first vector magnitude square root of 16 plus 4 plus 16 square root of 16 plus 4 plus 1. So that is, so making dot product in the numerator 4 16 plus 4 minus 4 by root 36 into root 21. It is 16 by 6 root 21. So making cancellation 2 3s, 2 8s, 8 by 3 root 21. So theta is equal to cos inverse of 8 by 3 root 21, which will be the required angle between the two surfaces. Next problem. Find the values of A and B such that the surfaces ax square minus byz is equal to a plus 2 into x and 4x square y plus z cube is equal to 4 may intersect orthogonally at 1, minus 1, 2. So here we have to find the values of A and B, and given condition is the two surfaces intersects orthogonally. Orthogonally means the angle between the two surfaces given as 90 degrees. That means n1 bar dot n2 bar is equal to 0. Since n1 bar and n2 bar intersect orthogonally, we have n1 bar dot n2 bar is equal to 0. Since theta is equal to 90 degrees. Also, since the two surfaces are intersects at this point must satisfy the two surface equations. Since the two surfaces intersect at the point 1, minus 1, 2, this point must satisfy the two surfaces. I am putting x is equal to 1, y is equal to minus 1, z is equal to 2 in equation 1, we get a into x square, ax square minus b into y minus 1 z2 is equal to a plus 2 into x. So here x is equal to 1. So we get a plus 2b is equal to a plus 2, or 2b is equal to 2, or b is equal to 1. Then equation 1 can be written as, then equation 1 becomes ax square minus b means 1, yz is equal to a plus 2 into x. And second equation, we have 4x square y plus z cube is equal to 4. Let f1 is equal to, or phi 1 is equal to ax square minus yz minus a plus 2 into x, and phi 2 is equal to 4x square y plus z cube minus 4. Now the first normal vector n1 can be find. Now n1 is equal to, what is the formula for n1? Grad phi 1, that is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function ax square minus yz minus a plus 2 into x. So this gives I bar into dou by dou x of this function 2ax, second term 0, minus third term a plus 2. Similarly, second one plus j bar into dou by dou y of this one minus z plus k bar into dou by dou z of entire term minus y only. And now grad phi 1 at the point 1 minus 1 2 is equal to 2a minus a minus 2 into I bar minus z and 2 j bar, y minus 1 means plus k bar, or this is a minus 2 into I bar minus 2 j bar plus k bar. All this is equation number 3, and this is, let it be n1 bar. Similarly, calculate the second normal vector, that is n2 bar, which is grad phi 2. Similarly, grad phi 2 is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function 4x square y plus z cube minus 4. So, now operating with partial derivatives, dou by dou x of this term 8xy, second term 0, third term also 0, plus j bar into dou by dou y, only 4x square, the remaining two terms 0, plus k bar into z cube term differentiation 3z square. First third terms will be 0. Now grad phi 2 at the point 1 minus 1 2 is equal to 8 minus 8I bar plus 4j bar plus z square, 2 square, 4 3s are 12 k bar, and call this is n2 bar, and call this is equation number 4. Now our condition is for orthogonality n1 bar dot n2 bar is equal to 0. That means the equations 3 dot product with 4 bar, 4 equation is equal to 0. Therefore we have n1 bar dot n2 bar is equal to 0. That is, n1 bar means n1 bar a minus 2 into I bar minus 2j bar plus k bar, the dot product with minus I bar, 8I bar plus 4j bar plus 12k bar is equal to 0. So multiplying minus 8 into a minus 2 minus 8 plus 12 is equal to 0. Minus I8a plus 16 plus 4 is equal to 0. Minus 8a plus 20 is equal to 0. Or 8a is equal to 20. A is equal to 20 by 8. It is 4 5s, 4 2s. Therefore, the required values are A is equal to 5 by 2 and B value is equal to 1. Next, eighth problem. If R bar is equal to xi bar plus yj bar plus zk bar and R is equal to magnitude of R bar, then we have to prove that in the first case gradient R is equal to R bar by R. R bar is vector, R is scalar function. And in the second bit you have to prove grad f of r is equal to f dash of r into r bar by r. So given r bar is equal to xi bar plus yj bar plus zk bar, and r is equal to magnitude of r bar, that is square root of x square plus y square plus z square. Then dou r by dou x, the partial derivative of r with respect to x. So I am making differentiation partially with respect to x, 1 by 2 root of x square plus y square plus z square into 2x. So 2 gets cancelled. This is equal to x by r. Dou r by dou x is x by r. Similarly, dou r by dou y is equal to 1 by 2 root of x square plus y square plus z square into 2y. So here also 2 cancel. The value is y by r. And last one, dou r by dou z is equal to 1 by 2 root of x square plus y square plus z square into 2z, or this is equal to z by r. So these things are common for all problems. If r bar is equal to xi bar plus yj bar plus zk bar, and r is magnitude of r bar, that is root of x square plus y square plus z square, then dou r by dou x, x by r, dou r by dou y, y by r, dou r by dou z, z by r. These things are common for all these type of problems. So please keep in mind. Now we consider grad r. In the first case, in the first bit we are supposed to consider. Now consider grad r. So we know that grad means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function r, that is I bar into dou r by dou x plus j bar into dou r by dou y plus k bar into dou r by dou z. But what is dou r by dou x? We know that x by r, dou r by dou y, y by r plus k bar into dou r by dou z, z by r. So 1 by r is common factor. I am taking outside 1 by r into xi bar plus yj bar plus zk bar. So this entire thing is r bar by r. That is the first solution. Grad r is equal to r bar by r. That is the first bit solution. Right? Similarly, we can prove the second one, grad f of r is equal to f dash of r by f dash of r into r bar by r. So similarly, consider b bit. Consider grad f of r. So what is the symbol del? Differential operator. We know that I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of f of r. So this is equal to I bar into dou by dou x of f of r. We know that f of r is a function of r, it is function of x, y, z terms. So differentiating partially with respect to x, we get f dash of r into with respect to x kabatti dou r by dou x kuda vastundi. I bar into f dash of r into dou r by dou x. Similarly, j bar into f dash of r into dou r by dou y. For the last one, k bar fixed, f of r and differentiate just f of dash of r into dou r by dou z. But what is our dou r by dou x? Dou r by dou x means x by r. Dou r by dou y means y by r. Dou r by dou z means z by r. and replacing. So f dash of r common term, take outside, I bar into x by r plus j bar into dou r by dou y by r plus k bar into dou r by dou z by r. So 1 by r is common term and taking outside f dash of r by r into xi bar plus yj bar plus zk bar. So this is equal to f dash of r by r into r bar. That is our result. F dash of r by r into r bar. Next, if r bar is equal to xi bar plus yj bar plus zk bar, and r is the scalar function magnitude of r bar, then prove that grad 1 by r is equal to minus r bar by r cube. Similarly, grad log r is equal to r bar by r square. So just previous problem on it. So first write the information. So given r bar is equal to xi bar plus yj bar plus zk bar, and r is equal to magnitude of r bar root of x square plus y square plus z square. Then we have, what is dou r by dou x? X by r, dou r by dou y by r, dou r by dou z by r. Already we have seen these values in the previous problem. Same, just copy it down. Dou r by dou x by r, dou r by dou y by r, dou r by dou z by r. Now first bit, consider grad 1 by r, del 1 by r. So grad means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of 1 by r. So now on operating 1 by r with each term, with each partial derivative, I bar into dou by dou x of this function. We know that 1 by r derivative minus 1 by r square with respect to x. That means you have dou r by dou x also. 1 by r derivative minus 1 by r square multiplied by dou r by dou x plus j bar into, and doing partial derivative with respect to y, 1 by r derivative minus 1 by r square into dou r by dou y plus k bar into minus 1 by r square into dou r by dou z. What is dou r by dou x? X by r. Dou r by dou x is x by r plus minus 1 by r, dou r by dou y by r. Similarly, k bar into minus 1 by r square into dou r by dou z is z by r. So here minus 1 by r cube is common term. So I'm taking outside minus 1 by r cube, we have xi bar plus yj bar plus zk bar. So the resultant is minus r bar by r cube. That is the required solution. Minus r bar by r cube. Right? So similarly, the second bit, grad log r is to be proved as r bar by r square. So B bit, similarly consider gradient log r. So we know that the del symbol I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of log r. Now I bar into dou by dou x of log r. So log r derivative 1 by r into dou r by dou x plus j bar dou by dou y of log r. Log r is a function of x, y, z. So we can do derivative with respect to x, y and z. So with respect to y just 1 by r log r ki. So I'm doing with respect to y means you'll get the factor dou r by dou y also. Plus k bar into log r 1 by r dou r by dou z. So now I'm replacing I bar into 1 by r. Dou r by dou x means x by r. Plus j bar into 1 by r into dou r by dou y. Y by r. Plus k bar into 1 by r into z by r. So common factor 1 by r square. So bracket lo xi bar plus yj bar plus zk bar. That is equal to r bar by r square, which is the required solution.